Hey guys, so we're actually going to take some short notes today, and the fact that it's just looking at kind of some weird numbers that dovetail into the notes we took on Friday. So we're just talking again about finding percent of a number. So this is still lesson 2-7 and finding percent of a number, which you're like, well, okay, we already did that, so how's this different? Now, just like we did in Chapter 4, we're going to talk just about, well, what if we have really large numbers or really, really small numbers? So finding percent of a number when the percent is greater than 100% or less than 1%. And so today's date is going to be 12/10/18. So I just have a couple of reminders. I think maybe I'll write them off to the right. In fact, hold on one second. I was going to see if I could make the page bigger, but I don't think I can at this juncture. So looks like I put a little dot here. Let's get rid of him. So I think what I'll do is probably write some notes off to the side, and then we can do the math underneath. So let's talk about when percents are greater than 100. So when percents are greater than 100%. Now, the process we talked about on Friday, which is just change our percents either to a fraction or a decimal and then multiply it by the other number, that process doesn't change. It's just the numbers that we get are going to be bigger or very, very small. So just a hint, when the percent is greater than 100, we're going to try changing the percent, or let's say converting, because that's a better word. Try converting the percent value to a fraction. And just as a reminder, our percent value is that number that the percent value is over 100. So that's how we will make a fraction out of it. So for example, 136% would be 136 over 100, because remember, percent just means divide by 100. And we're going to show it vertically, not horizontally. Okay? So let's talk about the other situation. When percents are less than 1%. So a suggestion I'm going to make is going to be to try converting. Ooh, that doesn't show up real well. I'm going to have to change that color. I'm sorry, my friends. I'm going to go a little bit darker. That's better. Try converting, it's still a little bright there, the percent to a decimal. Okay, and remember that percent means that we're going to divide by 100, but this time we're going to go horizontally. So that means you're going to move the decimal left 2 places. Okay, so an example would be, and this was one that was on your quiz, 32%, when I divide by 100, I'm going to move the decimal point left 2 places. So I'm going to fill up the blank with a 0, so we get 0.0032 or 32 hundredths. Okay, so those are just some suggestions I have. You can try to do it everything to a decimal. That's fine. It doesn't really matter, but just here's some thoughts. So I will practice on at least 2 of the examples will be for when they're over 100%, I will go with the fraction idea, and then the other one I will go to decimal. So you'll see both versions, okay? So let's start with this 145% of 320. So let's go ahead and try to convert this percent, 145%, and write the per 100 vertically. And then we're going to multiply by 320. So remember what we can do. We can create a fraction anytime from a whole number by just simply giving it a denominator of 1. So now I'm going to try to cross cancel. And first thing I notice is that I can divide a 10 out of each of those numbers on the diagonal. So now I have 145 over 10 times 32 over 1. But I also know that 2 goes into both of those numbers, so that gives me a 5. 10 divided by 5 is 2, and 32 divided by 2 is 16. But then what I noticed is that 5 can go evenly into 145. So 5 goes into itself once. It goes into 14 twice, which is 10 with 4 left over, and into 45 9 times. So what I have left is 29 times 16. So I go ahead and multiply, and I get 54. And let's see, I get 12, and 5 is 17. Put in a placeholder, and then 1 times 9 is 9, and 1 times 2 is 2. And I add those up, and I get 464. So that is 145% of 320. And that kind of makes sense because 100% would be 320, and then 45% is about half. So that would be, what, about 160. So we have 320 and 160. It's going to be somewhere around 480, thereabouts. It all works out. Looks good. Okay, so let's do another one like that. Let's go back to this color. And we're going to take 128% and write it vertically, the per 100. So we have a fraction. Of means to multiply, and then we have 550. So remember, we can always change the whole number into a fraction by dividing it by 1. And then we're going to start trying to cancel out any common denominators. So again, on the diagonal, ends in zeros, so that can divide out. And then I notice that 10 and 55 have a 5 in common. So I'm going to divide a 5 out. So 10 divided by 5 is 2, and 55 divided by 5 is 11. And then I notice that 2 goes into itself evenly, and into 128 evenly, since they're both even. 2 goes into 12 6 times, and into 8 4 times. So my problem is now 64 times 11. So I get 4, 6, placeholder, 4, 6. And I add up, and I get 704 is my answer. Okay, so let's see how this problem would look like if instead of creating a fraction, I did a decimal. So what I'm going to do is start with the decimal point in its place, which would be at the end of 275. I'm going to divide by 100, which is going to move the decimal point left 2 places. So that gives me 2.75 times 4. So I'm just going to do 275 times 4. So temporarily, remember, we forget about decimals, and we just multiply. So I get a 20, 28 and 2 is 30. I get 8 and 3 is 11. Then I go back and I want to place my decimal point in. So I look, and there's 2 digits after the decimal point, so my answer will also have 2 digits after the decimal point. So my final answer would just be 11. Okay, so that's a different way to solve the problem. All right, so let's go to having numbers less than 1%, and then we're going to try the strategy of converting to a decimal and then multiplying. So first thing we're going to do is divide by 100. So here's the decimal point. So I'm going to divide by 100. Now that ended up giving me a blank spot, so I'm going to have to put in a decimal point and a 0. So I get 0.003 or 3/1000ths, and we're going to multiply it by 200. So again, I'm going to temporarily suspend that there is a decimal point. So I'm just going to get 200 times 3,006. And then I'm going to count how many digits come after the decimal point. I see 1, 2, 3. So my answer will have 1, 2, 3 decimal points after it. And that gives me a final answer of 6/10. Okay? And then this one, I'm going to do the same strategy. So again, we're starting by dividing by 100, which gives me 0.0085, and then times 600. So off to the side here, I'm going to multiply 600 times 85. So I get 0,030. Put in a placeholder, I get 0,048. So I get 0,00115. And then I go back and I count how many digits came after the decimal point. 1, 2, 3, 4. So my answer, 1, 2, 3, 4, has 4 digits. Ooh, sorry about that extra dot. Has 4 digits after the decimal point. So the final answer will be 5 1/10. Okay, and this last one. Now this is something, this doesn't work super well with this, but I'm going to show it to you anyway because this is the misnomer that a lot of you had on the test or on the quiz. When I take a percent and change it to a decimal, I'm going to do it over here, is that it becomes 55, or to a fraction, I'm so sorry, it becomes 0.55 over 100. And then I can multiply by 220. A lot of people just dropped off the percent symbol and the decimal point and then just put 100 underneath it. Nope, you have to keep that decimal point. That percent number goes over 100. So I can do some simplifying. 0 can cancel with 0. Also 2 can go in there. So 2 goes into 10 5 times and into 22 11 times. And then 5 can go into 55. Now remember, it's not really 55, it's 0.55. So the point is still there, and I get 1, 1. So what I end up with is multiplying 11 times itself, which we should know from our multiplication facts is 121, but here's just your proof. Oops, sorry. There's 121. And then what I need to do is figure out how many digits come after the decimal point, and I see 2. So my answer is also going to get 2 digits after the decimal point. And my final answer is going to be 1 21/100. So that's a different way that you can solve the problem. But again, I've seen so many people make an error when there's a decimal in the numerator of the fraction. So I really, really, really encourage you to go the decimal route when you have a number that's less than 1%. All right, good luck with this, guys. Oh, by the way, Easter egg, here's your special word. Write it at the top of your notes. Doctor Who. Doctor Who. All right. See you later.